Good morning. In this video, we're going to talk about distribution. We're going to talk about what it is. I'm going to give some examples from the real world. We'll talk about how to expand expressions using distribution, and then we'll do a few more examples before you start on your work for today. So the first example I want to give you is this. Write an expression representing the cost of buying 3 PlayStation consoles and 1 game with each console you buy. So you're buying 3 PlayStation consoles and 1 game with each console you buy. Assume that 1 game costs £500. Okay, so let's break this down. Let's break this problem down a little bit. If we're just buying 1 PlayStation, so let's say 1 PlayStation and 1 game along with it, we would pay whatever the price of the PlayStation is. I don't know what it is, and it's not in the problem, so let's just call it P. And we would buy 1 game, which we know the price of 1 game is £500. So P plus 500, right? In this case, just like we said, P is the price of 1 PlayStation, and 500 is the price of 1 game. But we're not just buying 1, we're buying 3 of them, right? So you can take this expression, this P plus 500, and you can multiply it all by 3. So whatever P plus 500 is gets multiplied by 3. Another way to think about it is to say I'm buying 3 PlayStations, so 3P, and I'm buying 3 games because I'm buying 1 for each PlayStation, so it's 3 times, or let me use parentheses here, times 500. And I'm adding those 2 costs together to get the total cost. So both of these expressions are equally valid. Now let's try solving them both. So I'm gonna assume like a price. I'm just gonna say, like, what if a PlayStation was £7,000? So I'm going to write here. This is just to show you that these 2 expressions are the same. So I'm going to say assume P equals 7,000. Okay, so assume a PlayStation costs £7,000. And then we're going to evaluate both of those expressions. We're going to replace the P by 7,000 in this expression and do the same for this one. So over here, I would write 3 times 7,000 plus 3 times 500. In this expression, it would be, so it's 3 times, and then in parentheses, 7,000 plus 500. Okay? Now let's simplify each one of those separately. 3 times 7,000 here would just be 21, because 3 times 7 is 21, so 21,000. And then 3 times 500, 3 times 5 is 15. Then we put the 2 zeros, so 1,500. Okay? And on the other side, we're going to add what's in the parentheses first, since we're following the order of operations, in case you forgot. Right? Parentheses, exponents, multiplication, division, addition, subtraction. And so 7,000 plus 500 is just 7,500. And then this is multiplied by 3. 21,000, back to here. So 21,000 plus 1,500 would be 22,500. So this is our total price, total cost for 3 PlayStations and 3 games using this expression, right? So we're just using this expression. And then if I go to the other expression, the last step is 3 times 7,500. I'm going to work this out on the side here. So 7,500 times 3. You can see that 3 times 0 twice, so 0, 0. 3 times 5 is 15, so 5, carry the 1. 3 times 7 is 21, plus 1 is 22,500. So in the end, we got the same exact total cost, or same exact answer. So you can see that these 2 expressions are pretty much the same. Let me rewrite them on a clean page here. So we had 3p plus 500, and we had 3p plus 3 times 500. Notice that the main difference here is that I'm multiplying 3 by each term, whereas here I'm only multiplying 3 by the result of those two terms. This is actually the only exception to PEMDAS, so I want to make sure you write this down. It's the only exception to the order of operations, which is PEMDAS. In this case, instead of doing what's inside of the parentheses first, we can just multiply the 3 by everything inside. So we can say 3 times p and 3 times 500 before we actually solve what's inside the parentheses. And this is what the result would be. 3 times p is 3p. 3 times 500 is 3 times 500, which if we look back at the problem here, solving them would give you the same answer. And you can try this with any other expression, and we will in this video. Okay? This problem says a public transportation bus consumes 9,000 liters of fuel every year. For every day of lockdown restrictions, each bus saves 30 liters of fuel. So the normal consumption right now is 9,000 liters. During lockdown, each bus saves 30 liters of fuel for every day. So notice that for every day of lockdown, 30 liters of fuel are saved. Okay. Now, the town of Heliopolis owns 10 buses. Write an expression representing the amount of fuel consumed by the buses in Heliopolis. So let's start with just one bus. So let's look at just one bus we know it consumes 9,000 liters. This is for one year, right? Per year. Now, for every day of lockdown restrictions, we save 30 liters. So instead of consuming 9,000, we would subtract 30 from that for every day that we have lockdown, right? And so if it's one day, we just subtract 30. Let's say this is like 1 day, 2 days, 3 days. So if it's 2 days, we're going to subtract 30 times 2, which is subtracting 60. 3 days, we're going to subtract 30 times 3, and so on, right? So if we were to write an expression just for one bus, it would be 9,000 liters, this is the normal amount, minus 30 times the number of lockdown days. So we don't know how many lockdown days there will be this year, for example, because we're still in the beginning of the year. So we can just call it D. Okay? So 9,000 minus 30D. This is the expression, this is just for one bus. Right? Now it says Heliopolis owns 10 buses. So we have 10 buses. What would the expression for that be? And so we will just take whatever we found for one bus and multiply it by 10. So let me write this out. So it's 10 times, and then the total for one bus, so 9,000 minus 30D. Okay? Now, we can now expand this. So when we multiply like this is called expansion. Or it's called distribution, but the result would be the expanded form. So if we're going to distribute here, we're going to do 10 times 9,000. So 10 times 9,000. Since the 10 is positive, we can say plus 10 times negative 30D, because what's negative here is the 30, not the 10, right? So 10 times 9,000, that's just 90,000. 10 times 30 is 300. Positive times negative here, so it's negative 300D. And there we go. This is our expression for 10 buses. The amount of fuel consumed by 10 buses. Okay? Now, let's look at a few straightforward examples. And I'm just going to solve them straight away. I want to expand this 4 times n minus 2. And so 4 times n, 4 times negative 2. So I get 4n minus 8. In this case, negative 9 times r plus 7. So negative 9 times r, negative 9 times 7. Notice that I'm including a lot of negative signs here. So negative 9 times r is just negative 9r. And then let me even say negative 9 times 7. And so if we simplify this, it would be negative 63. This one is tricky. It says negative and then parentheses 5 minus 8. If there's nothing here, then you know that it's a 1. Okay, we've discussed this before, but this is just a reminder. So it's as if we're saying negative 1 times 5 minus 8. So negative 1 times 5, negative 1 times negative 8. Negative 1 times 5, this is negative times positive, so it's negative 5. Negative 1 times negative 8, this is negative times negative. So it's going to be positive 1a, or we can just write a. Last one, negative 8 times negative 9n. So again, we're multiplying with both. And then negative 8 times negative 5. So negative times negative, you would get positive 72n. And then negative times negative again is going to be positive 40. That's it for today. You have an assignment on MathSpace. Please email me if you have questions, request tutoring if you need to work through the assignment together, and I'll see you on Zoom. Bye.